So, finding the zeros. What are the zeros? What does that mean? The solutions, right? Find the solutions. And so, your first set of problems say, use synthetic division or your calculator to decide which of the following are zeros of the function. So they give us 4 possible solutions. And we have to figure out which ones of those are actual solutions. So let's think about that for a minute. So they're not telling us these are solutions, they're saying which one of these are solutions. How can we figure that out? Huh? Okay, somebody suggested plug them in. Plug them in for x. What is that going to tell you? So you're going to get an answer for y. How do you know if it's a solution? Very good, if it equals 0. Okay, so that's one method. You could take that value for x and plug it in for x. If y equals 0, then it's a solution. Okay? Another thing we could do, if we use synthetic division with that solution, what needs to happen for it to actually be a solution? The remainder has to equal 0. So you could do synthetic division with, let's say if we want to know if, remember, if these are solutions, these are values for x, right? So if we want to know if x equals 1 is a solution, we could do synthetic division. If our remainder is 0, then yes, it's a solution. If it's not 0, then no. And then you would have to do it again with -1. Check to see if the remainder is 0. Do it again with 2. Check to see if the remainder is 0. And then do it again with -2. That would be a lengthy process, right? There is a way that we can do this in our calculator to check to see if those values are solutions. Can anybody think of a way that we could use our calculator to tell us whether those x values are solutions?
Plug it in the table.
Very good. Put this in, put your function in as y1. And then what Jane says, go to the table. And what do we look for in the table? What? Find, right. It is a solution if y equals 0 at that point, at that x point. So we go to the table and we check. You're going to go to your table and we're going to check these specific x values. So I'm going to put them in order. -2, -1, 1, and then 2. So we'll go to the table and think about it. A solution is an x-intercept, right? It's the point where that graph crosses the x-axis. Y is always 0 at that point. And so when you look at the table, if you check x equals -2, if y is 0, then it's a solution. Now remember, think about the synthetic division. When we do synthetic division, we're checking x equals -2. Our remainder, this is important. Remember that your remainder is your y value at that point. So when you do synthetic division at x equals -2, when you get 0 for your remainder, that's the y coordinate at x equals -2. Okay? And so put this one in your calculator, and you're going to go and we're going to check to see which one of these are solutions. The directions for this problem do not say find all the solutions. They just want to know which one of these are solutions. Okay? Okay, everybody has it in their calculator? Or are you at the table? What is the y coordinate when x equals -2? 0. That means -2 is the solution. What is the y value when x equals -1? Very good, -18. It is not a solution. Okay? What is the y value when x equals 1? -24. Again, that is not a solution. It doesn't cross the x-axis at that point. although that is a point on this graph. So let me just tell you this. Think about this. If I did synthetic division with x equals -1, what's my remainder going to be? -18. That is the same thing as evaluating this function at that point. Just like y'all said, plug that in for x and see what y equals. That's doing the same thing, and that's what we're going to be doing tomorrow, which is just the same thing. You're going to plug this, but it'll say evaluate this polynomial at x equals -1. Your y value is your remainder, which is your answer. Okay, anyway. All right, so when x equals 2, what's your y value? 0. So the 2 out of these 4 that are solutions are x equals -2 and x equals +2. Okay, so try this one. Okay, what is my y value at x equals -2? So is that a solution? No. What is my y value at x equals -1? -18. Is that a solution? No. What is my y value at x equals 1? Is that a solution? And what is my y value when x equals 2? Okay, so that is my only solution, x equals +2. That is the only solution out of the 4 that they gave us, okay? There are ultimately how many solutions to this polynomial? 4. There are 4 solutions to this polynomial, which leads us to the next set of problems. Okay, so knowing how to find those easy solutions or those easy zeros using our calculator can help us with the next set of problems. Now, what we did on Friday was they said, find all the solutions given 1. So they gave you 1, and then you had to find the rest, right? And so we're going to be doing the same thing, except they're not going to give you 1. They're not going to give you 1 to start with. But can we find 1 to start with? Yes. We can use the table to find the easy solutions, and then we do synthetic division to shrink our polynomial down to where we can factor and solve it. Okay? And so let's look at an example of that problem. Now, don't copy all this down. I'm just going to explain it. If you want to, go on Edmodo tonight and you can copy down these steps. But let me just explain it, because we've already talked about it. So, to find all the zeros to a polynomial function, which means find all the solutions, graph it and look at the table to find all of the easy solutions. And the easy solutions are the x values in the table that have 0 in the y column. Okay, so we've already done that. Once you know what the first couple easy solutions are, you want to find as many as you can. Okay? Once you know what those are, you perform synthetic division with as many of those solutions that you have to shrink your polynomial down, so then you can factor and solve the remaining equation. Okay? Remember that the highest degree of the polynomial tells you how many answers you should have. And so an example would be this problem right here. So the instructions say find all the zeros. So y'all copy this down. Then, first thing we need to do, how many answers am I going to end up getting for x? 4. Okay? So we'll have x equals, x equals, x equals, and x equals. Okay? This will be my final answer once I figure out what all 4 of those solutions are. Okay? So let's go get the easy ones. Let's get our calculator to tell us as many of those as we can. So go put this in your calculator and go look at the table and figure out. Let's find the easy solutions. Okay, so when you go look at the table, what's my first solution? X equals -1, right? And what's the next one? X equals 2. That's all I can find in the table, right? The table only gives us x values in increments of 1. So unless your x value is a whole number, that's the only one that the calculator is going to give you. Okay? And so that means the other two answers are either not whole numbers or they're imaginary. Okay, so that was just a look ahead. All right, so now I have two of the solutions. So what you do now is you do synthetic division with both of those, but you do them one at a time. And every time you do synthetic division, it drops your exponent down by 1. So when we do synthetic division with x equals -1, our answer is going to start with x to the third, right? So then we take that answer and we do synthetic division again with x equals 2, and then our answer will start with x squared. And we can factor or solve something that starts with x squared. Okay? And so that's what we do. So we say x equals -1. All right? My coefficients are 1, -1, -5, 3, and 6. So I do synthetic division with this. So we bring down the 1. Everything under the line gets multiplied to -1. So 1 times -1, -1. Combine, -2. Multiply, +2. Combine -5 and 2, we get -3. Multiply -3 times -1, we get +3. Combine, we get 6. Multiply times -1, we get -6. And combine, and we get 0. We better get 0, because we know that x equals -1 is the solution, so our remainder has to be 0. Because we know that that y value is 0 at that point. So if you don't get 0 when you do this, you made a mistake somewhere. Okay, so now, if I were to stop right here, when I took this polynomial and divided it by the factor x plus 1, my answer would start with x to the third minus 2x squared minus 3x and plus 6, right? But I don't want to stop there. I want to shrink this polynomial some more. So I take my we already divided by this solution. Now let's take our answer and divide it by x equals 2. When I divide that by x equals 2, my answer is now going to start with an x squared term. And we can deal with that. And so you do this, instead of putting in all the variables and then working a whole separate problem, okay, save yourself some time. You already have your coefficients here, right? You already have them written out. So let's just do the same thing again with our next solution, x equals 2. Save yourself some leg. Okay? So we're shrinking this. Every time we divide by another factor or another solution, it's going to shrink that polynomial even more. And so we bring down the 1. So 1 times 2 is 2. Combine, you get 0. 0 times 2 is 0. Combine, you get -3. -3 times 2 is -6. And combine, and you get 0. And that should have happened, because that's another solution. Okay? It's like, think about it like this. It's like taking a number, 100. 2 is a factor of 100, right? So if you take 100 and divide it by 2, your answer is 50. So then if I take that 50 and divide it by another factor, it just keeps shrinking my number down. Does that make sense? Okay, so that's basically what we're doing. What was your question? Either way, it doesn't matter which solution you start with. That's a good question. So what happens if you started with x equals 2? You will still end up in the same place. Okay? So now, I don't have any more solutions to divide by. So now, I do have to put my variables back in and see what can I do to solve this last part. Okay? And so my variables, it started with x to the 4th. This answer would have started with x to the 3rd, right? So this answer starts with x squared. So x squared plus 0x minus 3. So now, once I divided by both of those, I have x squared. I don't need to put the 0x, it's just minus 3, right? So that that is as factored as I could get that. I can't factor x squared plus 0x minus 3. Okay, I can't use AC method with that. So I'm going to take that last factor. How do we solve? We take the factor, we set it equal to 0, right? So I take this and set it equal to 0, and now we're going to solve for x. Well, I don't need to do quadratic formula or anything like that. This is just, I don't have an x term. It's just the x squared term. So I take this negative 3 and move it over here, and it becomes positive 3 equals x squared. Now what do? Square root both sides, right? So x equals what? Very good. Plus or minus the square root of 3. So those are my last two solutions. Positive square root of 3 and negative square root of 3. So those are all three of my solutions, which is why my table wouldn't show these, because they're not whole numbers. Okay? It'll give you y values that are not whole numbers, but all the x values go in increments of 1. Because that's how we told the table to do that. That's the default on your calculator. It says the change is in increments of 1. Okay, any questions? Okay, let's look at, y'all try this one. Find all the zeros. Okay, I'm going to give you more time to work, but let me just make sure that we understand what we're doing. How many answers should we how many zeros are there? There's 4. So you should have x equals something, x equals, and x equals. That is always where I would start, so that you make sure you know how many answers you should have. Okay, so when you put this in your calculator, the easy zeros end up being negative 1 and 2. Those are your two easy solutions that you find in the table. Your table solution. Okay? So we do x equals negative 1. And we divide using that. And so it's 1, negative 5, 7, 3, and negative 10. So we bring down the 1. Everything gets multiplied by negative 1. So that's negative 1. And we combine, we get negative 6. Times negative 1 is positive 6. And we combine, we get 13. Multiply by negative 1, we get negative 13. Combine, we get negative 10. Multiply by negative 1, we get positive 10. Combine, we get 0. That's our remainder. Now we divide again using our second solution. So using x equals 2. Bring down the 1. Multiply, we get 2. Combine, we get negative 4. Multiply, we get negative 8. Combine, we get 5. Multiply, we get 10. Combine, we get 0. Now, it would be nice if I had another solution. If I had another solution, then I could divide again, and then I would end up with just a 1-degree binomial. That's easy, okay? But we don't. So, when I divided the first time, my answer would have started with x to the third. And then I divided again, so my answer starts with x squared. So it's x squared minus 4x plus 5, because that's positive 5. Did you find your mistake?
Instead of dividing the answers in the first one, I just did them separately.
Made a mistake? Okay. And so now we try to do our AC method, because that's the easier form. To me, it's easier than quadratic formula. Well, it's just easier to make a mistake with quadratic formula. So we try. Do we have any factors that multiply to equal positive 5, but when I add them, they equal negative 4? No. Okay? You cannot find those magic factors. They don't exist. So, good old quadratic formula. This is A, this is B, this is C. So, x equals negative b plus or minus the square root of negative 4 squared minus 4 times 1 times 5 all over 2a, which is just 2 times 1. Okay? So this is positive 4 plus or minus the square root of 16 minus 20 all over 2. So x equals positive 4 plus or minus the square root of negative 4 all over 2. Well, what is the square root of negative 4? 2i. So this is 4 plus or minus 2i all over 2. That can be simplified. Put each term over 2. So that equals 4 over 2 plus or minus 2i over 2. 4 divided by 2 is just 2. 2 divided by 2 is just 1, so it's 2 plus or minus I. Those are our other two solutions. 2 plus I and 2 minus I. Which makes sense. There's a reason why our table didn't give us those other two solutions. They're imaginary. Okay? Any questions? Now, if you look at this, if you get to this point and you look at this problem, you have to ask yourself, if I put each term over the denominator, will it simplify further? If it won't simplify further, then you could just leave your answer like this. But if it can simplify further, then you need to simplify more. Okay? Any questions? I have another one for you to try. And it's kind of like this one. Okay, find all the zeros. Okay, so I know that I should have 3 answers. Okay, so my first one, when I look at my calculator, my easy solution is x equals 2, and that's the only one I have. So, but that's okay, because when I divide by that, I'm going to end up with a quadratic that I can factor. And so x equals 2 is my first solution. So it's 10, negative 15, negative 16, 12. Bring down the 10, multiply, you get 20. Combine, you get 5. Multiply, you get 10. Combine, you get negative 6. Multiply, you get negative 12. And combine, and you get 0 for your remainder. So this is 10x squared plus 5x minus 6. AC method won't work. So A is 10, B is 5, and C is negative 6. So x equals negative 5 plus or minus square root of 5 squared minus 4 times 10 times negative 6 all over 2 times 10. So x equals negative 5 plus or minus. Once you simplify this, you get the square root of 265 all over 20. Okay? So x equals negative 5 over 20 plus or minus the square root of 265 all over 20. Don't make the mistake of making it look like it's the square root of all of this over, like put the 20 underneath the radical. It doesn't belong there. And so when you reduce that, you get negative 1/4 plus or minus the square root of 265 over 20. So my answer is negative 1/4 plus the square root of 265 over 20, and negative 1/4 minus the square root of 265 over 20. Okay? Questions? Okay, the next example, we're not going to have time to work through it. It's a word problem. However, I will put it on Edmodo worked out so that, because you have a couple of word problems from your homework like it. And so it will be worked out on Edmodo for you to go look and see how to do that, okay? The last set of problems is writing polynomials, okay? So let's look at the directions. It says, write a polynomial function of least degree that has real coefficients, that's the numbers in front of the variables, the given zeros, and a leading coefficient of 1. So if we have to write the polynomial and they gave us the zeros, what is 2, 1, and 4? What are those? They're the solutions, right? They're the zeros, so that means they're the solutions. They give us the solutions, they want us to write the polynomial. Okay? Well, if they give us the solutions, that means x equals 2, x equals 1, and x equals 4. If x equals 2 is the solution, what is the factor that goes with that solution? X minus 2, right? Because if I move the 2 over, that would be x minus 2 equals 0. We're working backwards here now. So the factor that goes with this is x minus 2. What's the factor that goes with the solution x equals 1? X minus 1. And what is the factor that goes with x equals 4? X minus 4. So if we have to write the polynomial, and those are your 3 solutions, we have the 3 factors. So we have to take these 3 factors and multiply them all together. So we have x minus 2 times x minus 1 times x minus 4. Now once we distribute everything, we'll have our polynomial that we started with. So this is why I thought it was important that we be able to go back and forth between solutions, factors, polynomials. Okay? And now, when you have 3 things that you need to multiply together, you multiply the first 2, get the answer, and then multiply it to the third one. Right? So you multiply these 2 first. So, x times x is x squared. X times negative 1 is negative x. Once I distribute that, I distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. And that's still times x minus 4. Okay, we need to simplify this before we move on. So that's x squared minus 3x plus 2 times x minus 4. Now, remember, I have 3 answers, so my polynomial better end up being a 3rd degree polynomial. It's going to start with x to the 3rd power. Okay? Which will. So now I have to take this and multiply it times this. So first I distribute the x squared. So x squared times x is x to the 3rd. Then x squared times negative 4 is negative 4x squared. So I'm done distributing that one. What do I distribute next? The negative 3x. So negative 3x times x is negative 3x squared. I line up my like terms underneath each other just because it makes it easier to combine them at the end. But if you're not comfortable doing that, then keep writing them in a straight row. Just sometimes you end up with like a whole bunch of terms. Okay, so negative 3x times negative 4 is positive 12x. I'm done distributing that one. Now I distribute the 2. 2 times x is 2x. 2 times negative 4 is negative 8. And when I combine all of that, I end up with x to the 3rd minus 7x squared plus 14x minus 8. And that is my polynomial that has those 3 solutions. Okay, in this problem it says, you're designing a candle making kit. Each kit will contain 25 cubic inches of candle wax, and the mold for the candle is shaped like a pyramid. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. What should the dimensions of your candle mold be? So here's a picture of what a pyramid looks like. They told us that the base was square, so that means all of the lengths of the sides are the same. So x and x, those are the same. And then the height has to be 2 inches less than the length of each side. So the height has to be x minus 2. Now, we know that the volume of a pyramid is 1/3 times the area of the base and then times the height. So using this formula, we will take and plug in the values that we do know. So we know that volume, they gave us the volume has to be 25 cubic inches. So 25 equals 1/3 times the area of the base, which is x times x, because the base is a square, so it's length times width. So it's 1/3 times x squared, and then times the height, which is x minus 2. Okay, so what we need to do to figure out, we need to solve for x. So to figure out how to solve for x, we need to set it equal to 0. All right? And so in order to do that, the easiest thing to do is to get rid of that fraction. And so to get rid of 1/3, we just multiply by 3. So if I multiply this by 3, if I multiply by 3 on the right, I have to multiply by 3 on the left. And so when I do, I end up with 75 equals, well, all of this cancels. So that's just x squared times x minus 2. So we distribute the x squared, and you get 75 equals x to the third minus 2x squared. Then if we're setting it equal to 0, we have to take 75 and bring it over there. So 0 equals x to the third minus 2x squared minus 75. So we take this and we put this in our calculator as y1, and we go look at the table and we find our possible values for x. That's the only thing you can really do right here. And so when we go look at our table, there's only one, we can only see one of those, quote, easy zeros, okay? And one of the easy zeros is x equals 5. So when we look at the table, when x is 5, y is 0. Only one of those x values, we know we have a possibility of 3 different solutions here, but only one of them can actually work, because you can't put in different values for x. Okay, so when you look at the table, you're only going to find one of those solutions. When it's a real world problem like this, only one value for x is going to work. And so this one gives us that value for x is 5. And so that means x equals 5. So that means the length and the width of the base are both 5. And that means the height is 5 minus 2. So the height is 3. So that answers our question. The question that it asks us is, what should the dimensions of your candle mold be? And so the base, the dimensions for the base are 5 inches by 5 inches. The length is 5 inches and the width is 5 inches. And the height has to be 3 inches. So that's your answer. So when they give you the formula, you have to plug in, you even plug in the unknown information, okay, you plug in the variables, set it equal to 0, and solve for x. Okay, so we worked this first one in class, so I'm going to finish working the second one. And so if these are our solutions, the factor that goes with x equals 1 is x minus 1. Then the factor that goes with x equals negative, because we have x equals 1, x equals negative 4, and x equals 5. So if we move all these to the other side, we can see what that factor is. So the second factor is x plus 4. And the third factor is x minus 5. Now we just have to multiply those out, all of those out, so that we can write a polynomial function. So when we multiply the first two, first we distribute the x. So x times x is x squared. X times 4 is plus 4x. Okay, we're done with that one. Now we distribute the negative 1. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. Okay, remember all of that is times x minus 5. So I'm going to simplify this before I move on. So that's x squared x squared plus 3x minus 4 times x minus 5. So now I distribute the x squared. So x squared times x is x to the third. X squared times negative 5 is negative 5x squared. I'm done distributing that one. 3x times x is plus 3x squared. 3x times negative 5 is negative 15x. Finish distributing that one. Negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20. So when I combine all of this, I get x to the third minus 2x squared minus 19x plus 20. And that is my polynomial that has these solutions. Okay, so here's another real-world application that I didn't get to in class. And so this one says, for the 25 years that a grocery store has been open, its annual revenue, which is represented by R, revenue is the money that it made in a year, R is represented in millions of dollars, can be modeled by this function. So once again, they're giving us the formula, where T is the number of years the store has been open. In what years was the revenue 1.5 million? So revenue 1.5 million, that's this. And so we write the equation 1.5 equals 1 over 10,000 times, and we're just copying, negative t to the fourth plus 12 t to the third minus 77t squared plus 600t plus 13,650. Okay? Now, I need to set it equal to 0, just like we did in the other real world application, and then we're going to have to solve for t. And so, before I can solve for t, I need to get rid of this 10,000. And so, if I multiply this by 10,000, that will cancel that out. So, I also have to multiply the other side by 10,000. Now, 10,000 times 1.5 is 15,000. So 15,000 equals negative t to the fourth plus 12t to the third minus 77t squared plus 600t plus 13,650. So we have to set it equal to 0. So that means I'm going to subtract 15,000 from both sides. So then I have 0 equals negative t to the fourth plus 12t to the third minus 77t squared plus 600t, then minus 1350. So you put that in your calculator as y1, and we go and we look at the table. Except we don't put t to the fourth, we put x to the fourth. Okay, so when we go look at the table, again, we're looking for those solutions, right? So when I look at the solutions, I see that when x is 3, y is 0, and when x is 9, y is 0. Well, unlike the other problem, okay, this we can have two answers, because what does x represent? Well, x is the same thing as t, and it tells us that t is the number of years the store has been open. So it wants to know in what years did they make 1.5 million? Well, in the third year, in year 3, and in year 9. They made $1.5 million. So that is the answer. You can have two answers in here because it is possible for 2 separate years for them to make that amount of money. In the other problem, it's not possible for you to have a different value for x when you need the volume to be exactly 25 cubic inches. Okay? You can't choose different amounts, different dimensions, You only need that one dimension. You need that one volume. It can't be more, it can't be less. It has to be equal to that. And so the only way it's going to work is if x equals 5. Okay, so that's why this problem is a little bit different. So when you're looking at these real world applications, you have to ask yourself if it's logical for you to have more than one answer. Okay, so once again, just like I told you in class, these are your homework problems, and we'll go over any questions that you have tomorrow.